awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun, kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. Alright, so now let's continue example 7. So video kali ini ada dua examples. Okay, example 7 and example 8. Alright, so this is the last video for subtopic 8.2 under equilibrium of rigid body. So next video we will continue with subtopic 8.3 under rotational dynamics. Okay, now let's read the question. So here we have a man raise a 10 kg joist of length 4 meter by pulling on a rope. So find the tension in the rope and the reaction at A. Means that we want to find what is the value of tension. So here we have T. Okay. And then the questions asks us to find the reaction at A. Okay. So kita akan ada reaction force here. Okay. So this is, we consider this as a pivot point. Okay. So now let's draw another force that we have on the joist. So we have another force which is the weight of the joist at the center here. Okay, we draw it straightly downward. Okay, so if here is 45 degree, means that here also 45 degree. Okay, so here also 45 degree. So now look at here. This angle is 25 degree. Okay, so means that here should be 20 degree. Okay, this angle should be 20 degree. Kenapa 20 degree? So kalau kat sini tadi 45. Okay, yang saya colourkan dengan warna biru ini. So this is 45 degree. Means that ini pun sudut berselang-seli kan. So 45 degree. So if here is 25, so the remaining angle here should be 20. Okay. Sebab ini adalah selari dengan bawah ni. Awak lukis ni selari sepatutnya dengan sini. Okay, the ground. And ini adalah sudut berselang-seli. Okay, 45 here. Okay, and this is also 45. Okay, kenapa saya nak kira 20 tu? Kejap lagi kita akan tengok lah. Kita perlu guna ke tidak. Okay, so we want to find tension. Alright, so I will start with total torque. Okay, saya nak mulakan dengan total torque. Since the pivot is at A, so saya tulis total torque A is equal to 0. Okay, and then look at on the diagram here. So since this is the pivot, so torque due to the reaction force should be 0. Okay, and then we have weight of the joist, and then we have tension. Okay, so kita letaklah. So torque due to the weight of the joist plus torque due to tension T equal to 0. Kita totalkan dulu and then we determine the direction. Okay, so we start with this one. Okay, the weight of the joist. So start from here, the pivot. Okay, so this is the angle between RJ. RJ means that distance from pivot A, okay, to this point. So RJ sebab separuh daripada joist tadi. Okay, dia dah bagi length dia adalah 4 meter. So kalau separuh, RJ sepatutnya 2 meter. So saya akan letak 2 meter. Okay, and this is the weight of the joist. So it is equal to 10 kg times 9.81. So it is equal to 98.1 Newton. Okay, and then remember the angle between RJ and WJ. So here is equal to 45 degree. Kan? Ni triangle. So 180 minus 90 minus 45, and then kita akan dapat sini 45. Okay, and how about the direction? So the direction is clockwise direction, so it's negative value. Okay, and for the direction of torque due to the tension of the string pun kita boleh lukis. Okay, kita lukis daripada pivot at point A and then kita naik atas. Okay, so in this case we consider this point is at the end of the joist. Okay, and then this is the T, tension. Alright, and then the angle here, okay, let's use another color. So the angle here is 25 degree. Alright, so from A to this point, RT is equal to, RT is actually the distance from A to this point where the tension is exerted on the joist. Okay, so RT, kita consider daripada A ke sini ke B. A ke B adalah 4 meter, the length of the joist. So 4 meter. Okay, and then tension kita tak tahu berapa. Alright, and the direction of the torque due to the tension should be anti-clockwise. So dia positive. Boleh? So tension kita nak cari. And then let's substitute in this equation. Okay, kita masukkanlah, kita totalkan. So total torque at point A is equal to torque due to the weight of the joist plus torque due to the tension. Okay, so torque WJ is negative since it is clockwise direction. So saya akan letak RJ times WJ sin 45 degree. Okay, plus, okay, so this one is anti-clockwise, should be positive. So we have RT times T, kita tak tahu berapa, sin 25 degree, and it is equal to 0. So RJ kita dah ada nilai dia, kita boleh masukkan 2 times WJ is 98.1 sin 45 degree. Okay, plus RT is 4 meter times T times sin 25 equal to 0. Okay, jadi 4 times sin 25 ni kita dah boleh settlekan. Mana yang boleh settle, kita settlekan. Okay, so kita akan dapat negative 138.73 equal to, kita bawa ini pergi sebelah, dia akan jadi negative 1.69T. Okay, kita kira yang ini. 4 times sin 25, you akan dapat 1.69. Okay, alright, therefore you kira T, you akan dapat 82.09 Newton. Okay, T is a tension, so T is tension, where tension is a force, so unit dia Newton. So kita dah jawab untuk capital T. And now we want to find the reaction force at A. Macam mana kita nak kira? So tengok dekat sini, we want to calculate the reaction force at point A, tapi kita mesti kira dulu Rx berapa, Ry berapa at point A. Okay, kat A sini. And then baru kita boleh kira the reaction force at point A, okay, by using this equation. Alright, so now look at this diagram. Okay, so here we have T. Okay, so we need to resolve T into Tx and Ty. Tengok dekat sini So Ty is straightly downward. Okay, so dia akan kita akan dapat T sin so this is Tx. Okay, so Tx equal to T cos 20. Sebab tu tadi saya cari yang 20 degree ini. Okay, so ini Ty adalah T sin. Alamak, tak muat ni. Saya tulis kat sana sikit. Ty is equal to T sin 20 degree. Okay, sebab T tu ada angle. So kita kena resolve kepada X and Y component since we want to use another concept, okay, for the equilibrium of rigid body where total force in X component is equal to 0. Tadi kita dah guna yang torque. Okay, so kita akan guna ini pula. Okay, total Fx is equal to 0. So tengok pada diagram ni kita ada Rx. Okay, obviously kita ada Rx. Okay, So apa lagi in X component dan juga TX. RX dan TX, where the direction of RX is to the right, so positive, and TX is to the left, so negative. Okay, so saya akan tulis RX plus negative TX equal to 0. Therefore, I can calculate RX is equal to TX, where TX saya dah resolve dah tadi. TX is equal to T cos 20 degree. Okay, jadi untuk kira TX ni penting you tahu angle yang rapat dengan TX ni adalah 20 degree. Sebab yang kat sini susah kita nak tahu kan berapa kan. Okay, kita yang 25 ini adalah angle antara tension dan juga joist ni. Okay, so nak cari equation untuk TX dengan TY. So saya kira angle between T tension with the horizontal line here TX. Kan? So kita gunakan maklumat here is 45 degree. So kalau total sini pun yang warna biru ini 45. So 45 minus 25 here. So the red color here should be 20 degree. Okay? So kita masukkan dalam sini T tadi kita dah dapat 82.09 cos 20. So kira dekat sini RXU akan dapat 77.14 Newton. Okay, kita belum selesai lagi. And then we proceed to the second part. Okay, which is total Fy is equal to 0. Okay, so kita tengok pada diagram kita ada berapa force in Y component. So we have Ry upward, Wj downward dan juga Ty downward. So I will write Ry is positive since the direction is upward, plus negative Wj plus negative Ty equal to 0. Okay, so tak muat ni, saya nak kena gerakkan sikit ke depan. Alright, so now let's substitute here. Okay, saya buat garisan dulu. Okay, so Ry, we want to find Ry is equal to Wj plus Ty. So Wj kita dah tahu nilai dia 98.1 Newton, plus Ty is T sin 20. So T sin 20, T kita dah dapat tadi 82.09 sin 20. Kalau tak nampak mana sin 20, sini yang saya dah resolve tadi, Ty. Sini adalah TX. Okay, so tekan calculator. So Ry equal to 28.08 Newton. Therefore, the resultant ataupun reaction, okay, the resultant reaction force at point A is equal to square root. So Rx squared 77.14 squared plus Ry squared, and the answer is equal to 147.9 Newton. Okay, and this is the magnitude. So the direction, kalau kita nampak ni R ni, kita tak tahu ni R ni macam ni ke kan. So kita nak tahu angle dia berapa ni yang saya hitamkan ni. Okay, so theta is equal to inverse tangent Ry over Rx. You masukkan nilai, you akan dapat theta is equal to 58.6 degree. Okay, so finish example 7. Let's proceed to the last example for subtopic 8.2, example number 8. So now look at example number 8. So here we have a 45 kg 5.0 meter long beam is supported but not attached to. Okay, dia hanya support dengan dua point ini. So point A, point B. Okay, tapi dia tak attach lah, tidak dipakukan macam tu Okay, the two posts in the figure 2. Okay, so we have two posts here. A 20 kg boy starts walking along the beam. So dia berjalan. How close can he get to the right end? Kita pilih lah, contoh kalau kat sini kan, point ini. How close can he get to the right end of the beam without it falling over? So kalau dia terjatuh, ceritanya kat sini, kita nak cari mana point, okay, that close to the right end of the beam. So kita nak kira distance ini, saya letaklah distance ini X. Kita nak kira X ni berapa without it falling over. So, dia boleh bergerak sejauh mana tanpa dia jatuh. So, we need to consider when this boy is start to falling down. Okay. So, what happened to this point? Point A. Okay. At point A. Okay. We need to consider. Okay. It is floating. Dia macam terangkat sikit kan. Macam floating. Itu maknanya itu adalah moment di mana dia tak boleh gerak lagi ke depan. Kalau gerak ke depan lagi sikit, dia akan jatuh. Okay, dah tak balance. Okay, so we need to consider this point, okay, as a floating point. Okay, awak boleh imagine lah. Contoh kalau awak jalan daripada sini, okay, you start to walking here until certain point. Okay, we consider at this point, okay, the beam start to float. Okay, the beam start to float at point A. Kalau dia jalan ke depan lagi, move forward lagi, what happen? The boy will falling over. Boleh. Okay, so we need to consider. So at point A, no contact between the beam and the post. Okay, so we consider the beam is floating. Alright, so tak ada normal force lah dekat A. Okay, so sebab dia dah floating, tak ada contact, so no normal force at point A. So now let's draw all the forces on the beam. We consider the weight of this boy. So letak WB, W boy lah kan. Beam kita ada normal at point B, and at the center, ni saya padam lah orang ni. Okay, so at the center of the beam we need to consider. So this is the uniform rigid body. So we need to consider the center of the gravity for the object. So the weight of the beam, okay, we locate at the center of the beam, tengah-tengah. Okay, so sekarang kita nak kira X kan. So I will use total torque is equal to 0. Okay, kita still consider, okay, that the system is equilibrium. Okay, maknanya sebelum budak itu jatuh kan, sebab soalan kata how close can he get to the right end of the beam without it falling over. So without it falling over tu, sebelum dia terjatuh lah, we consider still balance. Okay, tapi kita kena assume yang ni at point A ni dia dah terangkat sikit, dah start to float. Okay, so kita kena consider macam tu. Okay, and then B, and then we need to consider B as the pivot point. Okay, so now if B is the pivot point, so torque due to the normal force at point B akan jadi 0 lah automatically. Okay, so kita akan letak, kita ada torque due to the weight of the beam plus torque due to the weight of the boy. Okay, and it's equal to 0. Okay, so now look at the direction, clockwise or anti-clockwise. So this is the pivot point. So kita gerak ke sini. So RB, berapa jarak dia? Kalau panjang ni ada 5 meter. Okay, so kalau sini adalah 2.5. Okay, and then given that from A to B is 3 meter. So kalau sini 2.5, so here should be 0.5, right? 0.5 meter. So RB 0.5 meter. Okay, so daripada pivot pergi ke sini, RB 0.5 meter, and then this is the weight of the beam. So 90 degree. So weight of the beam 5 times 45 kg. 5 tu dia punya panjang. 45 kg times 9.81. Okay, so boleh kira lah weight of the beam, 441.45 Newton, and the direction is anti-clockwise, so positive value. Okay, and then we proceed to the second torque due to the weight of the boy. Okay, so from the pivot, and this is R boy, and this is the weight of the boy. Weight of the boy is 20 kg times 9.81. So berat dia 196.2 Newton. Okay, 90 degree. So R boy ni berapa pula? Okay, so kita tak tahu ni berapa. Okay, kita tak tahu ini berapa. Kalau ini adalah X, tengok sini baik-baik So kalau sini adalah X, okay, means that from here, daripada B ke sini, sepatutnya kalau 3, panjang beam ni adalah 5, so sini sepatutnya 2 meter. Daripada B ke hujung beam ini 2 meter. Okay, so kalau yang ini daripada position of the boy to the pivot point B adalah 2 minus X. 2 minus X, tolakkanlah. Kalau panjang sini adalah 2 meter, so here is X. So the balance distance here from the position of the boy to the pivot here should be 2 meter minus X. Okay, so saya letak sini 2 minus X. Okay, so now let's write. So this is the clockwise direction, so negative value. Okay, so negative value. Okay, so now let's substitute torque due to the weight of the beam. So positive RBWB plus negative R boy times the weight of the boy equal to 0. So let's substitute 0.5 times 441.45 minus R boy. R boy kita tak tahu tadi kan, 2 minus X times W boy, iaitu 196.2 equal to 0. Okay, let's try to settle this one. This should be 220.725 equal to, okay, kita bawa semua ni, to the other side. Okay, kita positifkan dia. So dah akan jadi 2 times 196.2 and X times 196.2. Okay, dah akan jadi 392.4. Okay, ni negatif, bawa pergi sebelah jadi positif. Negatif, negatif, positif, bawa pergi sebelah akan jadi negatif 196.2x. Therefore, settle this equation. Okay, we try to solve. X is equal to 0.875 meter. Okay, maknanya position of the boy, okay, before he falling over, okay, from the right end of the beam, X is equal to 0.875 meter. Okay, so finish example number 8. So for the next video, we will try to solve some examples under subtopic 8.3, which is rotational dynamics. Okay, jumpa lagi. Assalamualaikum. Bye-bye.